Before starting this tutorial, be sure you're up on the basics of C#. If you don't know anything about the language, I have a tutorial on C# with a link down below in the description. Alright, my name is Jonathan Hopp and I'll be your instructor today. Today we're going to talk about LINQ, Language Integrated Queries, which is a highfalutin way of saying you've got a big pile of data and you've got some questions. Alright, so at the end of the day, what LINQ helps us to do is it helps us to query or ask questions of our data to get answers. And you might have, there's all kinds of data out there. Personal information, sales records, history of movement, populations of countries. Like, there's all sorts of data out there. And you need to take these big sets of data and ask questions and say, okay, cool, given this big set of data, I'd like to know X, Y, or Z. LINQ helps us do that in C#. LINQ is an extremely powerful tool that we get that really shines. It really is what makes C# very special, easy to use. All right, so enough blabbing. Let's actually get to start talking about how we use LINQ. LINQ is for collections of things. When I say the word collection, what I mean is more than one piece of data stuck together. So if you have a singular grade, like this, for example, that is a singular piece of data. That is not a collection. Int grade equals 0. This grade variable is just a single point of data. It doesn't go with anything else. It's not a collection. Okay, line 3, grades is a list of double, which is great. And let's just say that this represents a student's exam grades throughout the entire semester. So they did really well on some exams out of 100. They didn't do some other exams very well, and it just depends, right? So cool. Now, this is a collection because it's a list. Now, LINQ works on other kinds of collections too, all right? But we're going to work with lists first because it's pretty much the easiest. And I think it's very easy for beginners to get a grasp of it. All right, so because we're going to do grades, and I'm going to ask a question. What is the student's average grade? One of the best ways, I think, to learn about querying, and the way I think it sticks in students' heads the most, is to focus on the question, okay? Because again, you're querying something. You're asking a question of the data. That is what we are doing. So what is your question? What question can this data answer for you? So there's enough data here for us to answer the question, what is the student's average grade? Now let's think about it. How would we do this normally? Okay, just forget LINQ for a moment. How would we do this normally? You'd use a for loop. I could make a placeholder variable to hold the sum. Then I could loop through the list like this, okay? And then I could do sum plus equals, and then do grades at I, and then at the end of it, oops, let's do it as a double. Okay, and then we will do console.writeLine. We'll do string interpolation. We'll do the average grade is, and then we'll do sum divided by grades dot count. Okay, so here we've got a placeholder variable. I loop through every individual item of the array and add it to this sum variable. So as I go along, it continuously, sums up the list. And then at the end, I take the average. Remember, the average is the sum of all the elements divided by the total number of elements. Now, this would be an example of imperative programming. All right, what I mean by that is you show step by step, right? Every bit of code is here about how it is I figured out the average. I had a placeholder variable, I had a for loop, what we did inside the for loop, and then eventually how we got the average. Everything's kind of spelled out. If a good way to think about it is there's basically two ways of programming, kind of. It's imperative and declarative. All right, so this is the imperative approach. The declarative approach is not so concerned with the step-by-step and how we got there. If you're having trouble understanding the difference between the two, the best way I can explain it is picture yourself going to a restaurant and you want to go sit down and eat, and the host comes up to you and says, hello, sir, table for two. And you're basically just sort of you walk up to them and you're like, okay. In the imperative approach, when you walk up to the host, what you would do is you would say, grab two menus, turn 90 degrees, walk 25 feet, then place the menus down on the table opposite one another, turn 45 degrees towards the drink station, walk 5 miles per hour towards it, put our drink in the glass. It would be step by step by step by step, okay, about how I would like you to seat us for dinner. The declarative approach would be walking up to the host and going, table for two, please. and letting the host do all the details themselves about how it is that they're going to get, seating you and getting your drink and all that good stuff. All right, declarative is more focused on the end result, not so much on how we got there. And the imperative result, the imperative way is going to look at like all the steps you did in order to get the result. All right, so LINQ helps us to write code declaratively in a lot of ways. All right, so instead of doing all this stuff, now again, nothing wrong, absolutely nothing wrong. If I run this, okay, I'm going to get the average grade is 83.76, a bunch of other gobbledygook, right? 83.76, like that works. Okay, that works. There's nothing wrong with this. But let's say I didn't want to write all like this big block of code. So I'm going to go ahead and comment it out, and we're going to do it the LINQ way. So I'm going to call it the LINQ way. All right, I'm going to do console.writeLine grades.average. All right, so where on earth did this average method come from? Okay, grades is a list. What kind of data is this variable grades? This variable grades, the type of data it is a list of doubles. All right, and because it's a list, we have LINQ methods. So if you do grades dot and take a look at IntelliSense, a lot of these methods, not all of them, but a lot of them will come from LINQ. Okay, and because it's a list, we get all of them. We get access to every last one of them. So it's really kind of cool. It's like I said, it's built in. We didn't have to like install anything or do anything special. It just comes out of the box, which is amazing. All right, so we did grades.average, and now we can basically get the same result. I'm going to go ahead and run it again. And there you go, 83.76 and some gobbledygook. All right, so now we have two different ways of getting to the same result. So we could write it declaratively, which is just grades.average, or we could write it imperatively, which is using a for loop and a placeholder variable and, writing out every step. Which one's better? I'm not going to get into that. I honestly feel that as long as you get the right result, you're fine. Like, that's the point of engineering. Is like, we drive over the bridge and it doesn't collapse ever, right? That is the point. How we got there, if we have to like do one way or the other, that's fine. However, I do feel that it's a lot easier to understand like just doing grades.average, right? Like when you look at the average method, you don't really know as the person who's using the method, like how this average thing is actually working behind the hood. And you also don't really care. Okay, that's the main thing. I don't really care. Like, average is going to do exactly what I think it's doing, which is summing up all the elements and dividing them by the number of elements. Like, at the end of the day, that's what averages are. All right, so instead of writing all this, I could just write grades.average, and then I'm done. Okay, so I kind of like that. All right, so we're going to do the LINQ way, because that's what we're learning. All right, so now we've got a way to do the average. There's other methods called aggregate methods that we are basically able to do to, like, get information from this data. So for example, let's say I just wanted to get to sum up all of the grades in the list. All right, so we're going to do console.writeLine. All right, and then we're going to do screen interpolation. The sum of all the grades is, all right, and then we're going to do grades.sum. Okay, it's really just that simple. That's the cool thing about LINQ. Like, I want the sum of stuff. Okay, well, we'll just name the method sum. Like, there's no reason to not name it that. So let's go ahead and run it. All right, so the sum of all the grades is 1,089. And see how quick it does the calculation for us real quick. And the cool thing about it is if, like, this list were to ever change, let's say I added, like, I don't know, like a couple more values to it. Let's say I add some more values to my grades, and LINQ will just, calculate it. Okay, now the average changed and the sum changed, right? That makes sense. So there we go, right? Now that's really cool. All right, so we've got average, we've got sum. Let's say my question, so this will be, what is the sum of all the grades? Remember, I like learning LINQ through asking questions. Like, what is the question we are trying to ask? So, for example, another question we could ask is, what is the highest grade out of all grades? Right? To get the maximum grade, so which of these numbers is the highest, okay, we are going to use grades.max. So I'm going to do console.writeLine. The greatest grade in the list is grades.max. Bam. All right, let's run it. Grades.max. Okay, it's 100, right? There's no other higher than 100. Now the cool thing is that it doesn't really matter like where 100 appears in the list. There are two 100s, but max doesn't answer that question. 100 is the biggest number. It doesn't matter if it occurs 5 times, 10 times. If it occurs at least once, right? It's the highest number. Now you're thinking, well, what about the lowest number? What is the lowest grade out of all grades? Well, if this one's called max, then its opposite is most likely called min, right? So what is the lowest grade in the list is grades.min. Let's go ahead and run it. There you go. Lowest number is 12. All right. So this is pretty cool. We can do the average of the grades. We can do the sum of the grades, maximum of grades, min grades. We can even ask, like, how many grades are there in the list? How many grades do we have in the list? Okay, console.writeLine. The total number of grades is, and we're going to do grades.count. Okay, grades.count. And this method is going to basically just count up all the grades in the list. So let's go ahead and run this. Right, there are 16 grades in the list. Right, so these methods here, average, sum, max, min, and count, can give you a taste of what LINQ is doing. What LINQ is basically for is we have a question, LINQ has the answer. Okay, when you have some data that has, some data we have, let's say, like, in this case it's grades, it could be, whatever your imagination takes you. And we get methods out the box that are able to answer questions, okay, about this data, which is the core of LINQ. So now we've learned some of the aggregate methods. Okay, there's way more we can do with LINQ. We'll start that in the next section. So now I have a list of names. Okay, this is a list of string, and you can imagine the context for this data. Maybe they're like, I don't know, Premium Plus members. They're people who subscribe to our newsletter, like whatever. Okay, imagine something. All right, now we're going to do the where clause. So what we're going to do is we're going to do var names. Let's do var Jones is equal to, and let's say the question. So again, we always start with a question for what we're querying. Give me a list of people named Jones. Okay, so maybe their last name is Jones. Like, that's what we're looking for. All right, so that's our question. Okay, our question is, I'd like a list of people named Jones. Like, who are the people whose name contains Jones? Let's just say that. Okay, cool. No problem. So what we're going to do is we're going to do var Jones equals, and then we're going to do names dot, and here's where we're going to learn a new very, very important clause in LINQ. Okay, so it's like, I think of like LINQ as a bag of tricks. All right, so here's your next superpower that LINQ gives you. It's where. All right, where allows us to filter out things we want from things we don't want. At the end of the day, that is what where does. Where allows you to filter out the things you want from the things you don't want. Okay, so again, where is super flexible and super powerful. I want all the people who live in Florida over the age of 65 who don't like oranges. I want everyone who lived in Germany from 1985 to 1992 who enjoy ping pong. Like, you could slice that cake however you want. As long as you've got the data and the data is in there, you can slice the cake however you feel like with where. Right, now inside where, we're going to put what's called a lambda. Now you might be saying, well, what the heck's a lambda? So like, what the heck's a lambda? All right, a lambda is essentially, I think of it like a very, very pared down function. Here's what I mean by that. Let's say you had a regular method. String, introduce yourself, string name, return, hello there, okay, plus name, plus exclamation point. Run-of-the-mill method, okay, nothing special. If you don't know much about methods in C#, my advice is to go look at my C# introduction video, which covers that. So go ahead, get some popcorn. It's about 3 hours. It covers this, so you'll be able to get all up to speed. Okay, cool. So we've got this method, string introduce yourself, which takes in a name and returns hello there name, right? Pretty easy. Now, let's do a little thought experiment. What if my goal was to rip out everything in here that was not absolutely necessary? Okay, I only want things that are absolutely necessary. Well, if I'm only going to use this method once, I don't need the name. We have names for methods. This part is the name here. Okay, for those who don't know, the reason you name a method is because you want to reuse it. So like, introduce yourself, Joe. Introduce yourself, Bob. Like, right? Like, you want to take introduce yourself and use it over and over and over again. So you need a name to call it by. But let's say, for example, I was only ever going to use this method once. It was like a one and done. It's like, it's like a paper plate. You eat on it and then you throw it away. If that's the case, I don't really need this name. I can get rid of it, right? I can be done with that. And since it's returning a string, I could just basically say like, hey, this returns a string. Like I know it's returning a string because I have the return keyword and this part's a string. So I'm going to go ahead and just be like, nah, bro, I'll just get rid of that string part. I don't need it. I'll need this part, the string name, because that tells me what's coming in. I do need to know the parameters, okay? That's part of the function. Functions take things in, functions put things out. I don't need the squiggly braces. I really don't need them. They're kind of crap in my style. I don't really want them. What if I were to separate the inputs from the outputs with an arrow? Okay, like what if I were to do that? Like what if I were to do like inputs and outputs, and maybe I could like do them with an arrow? Like that would be great, right? Like so then I could not even need the return keyword necessarily. That would be cool. Like I could probably do that. It doesn't compile because you don't use it like in this case, but this is essentially the idea behind a lambda. A lambda is a stripped down function. It has no quirk, no bells, no whistles. It just shows you the inputs and the outputs. It's on, you know what I'm saying? It's just the function without anything special on it. So let's use them with the where clause. I'm looking for people whose name has Jones in it. All right. So John Jones, Bob Jones, these are just strings. So basically what we're going to do is we're going to look through the string and say, hey, does this string contain Jones? If it does, I want it. All right, so inside the where, we're going to use a variable. We're going to use an arrow function. So we're going to do x equals, let's do x dot contains Jones. All right, let's break this down for a moment. Okay, so this is a method. This is a little function. Again, we stripped off everything that we did not need. Okay, it's anonymous. It does not have a name. Okay, this variable x over here, hover over with your mouse, you'll see it's a string. This represents, in your head, you can think of it as representing each one of these. This where is going to loop through this list, and it's going to basically go up to each element. Hey, does this string contain Jones? Yes or no? Yes, it does. Stays in. Then it'll go to John Jones. Does this string contain Jones? Yes, stays in. Does this contain Jones? Nope. And if it doesn't contain Jones, it will just, keep going. Okay? It's going to eventually loop through everything. This is going to, you could think of it as like this condition is going to be run for every single element inside the list, one by one by one in the background. You won't see it. All right? Now, what I'd like for it to be a list at the end. So where does not give you a list. Okay? The where method does not return a list. It returns this IE enumerable. All right? IE enumerable is difficult to understand at first. I'm going to go more into it like later on when we talk more about like looping through things. But you could basically think of it as an interface that represents things that can be iterated through. Okay, in layman's terms, it's an interface or basically a description of a group of things, and that description is that hey, this group of things are things you can loop through, that you can iterate through them. All right, so we could just instead of doing var, we could do enumerable of string. Okay, Jones equals names dot where x arrow x dot contains Jones. Okay, and that would be fine. If you like a list, okay, instead of this using this interface, let's say we wanted to actually have a concrete list, right? So what we could do is instead we could do list here, but we'll get a compilation error. So it'll be like, hey, bro, like this gives me IE enumerable. This is a list. Oh, what to do? We can turn this IE enumerable, basically this like list of things we can count through, and actually turn it into a concrete list of string by using the list method. Okay, so I'm going to do names.where x arrow x dot contains Jones dot to list, and now I have a list of string. Now I can loop through it. Okay, so for each string name in Jones, console.writeLine name. Right, and this will give me everybody in the list whose name is contains Jones. Let's run it. Okay, Bob Jones and John Jones. All right, so see how where gave me the things I wanted, which was people whose name contains Jones. All right, and then everyone else was just like, I don't care, like I don't want them. All right, that's what filtering means. Okay, filtering. I think of filtering like you're baking, like you're boiling pasta, like you're making spaghetti. And you put the spaghetti in a colander, which is that big thing with the sieve in it with all the holes. So that way you can take the hot water, have it go down to the sink, and you can keep the yummy noodles. All right. So where it works like that, you want to, you want the spaghetti, the thing that you're looking for, the thing that you want, and everything else can just kind of go. Okay, so again, the syntax is where x arrow x dot contains Jones. Inside the where, we can do all kinds of things. Okay, the where clause is super duper powerful. I just did this as an initial example to make it easy. And remember, where does not return a list. Where returns an object that implements IE enumerable. Okay, something that implements that interface. If you want an actual concrete list, you must use the toList method at the end. We're going to do this in the beginning. I'll do more with IE enumerable later. It's a little more abstract. Okay, I feel that when you're just starting with LINQ, working with lists and being able to iterate through them and console.writeLine is you're able to more easily see what you're doing. All right, so again, we're going to do list string Jones equals names.where x arrow x dot contains Jones dot to list. And that'll give you a list of people whose names contains the string Jones. All right, so there you have a sense of what where does. Let's kick it up a notch. So far what we've been doing is we've been working with like simple pieces of data like strings and integers. Let's use some classes. All right, so as promised, we're going to kick things up a notch. We're going to use classes. Okay, so I've got a superhero class here. If you don't know what a class is, that's fine, but like I would recommend going over to my introductory C# tutorial where I discuss what a class is and what objects are. But I think even if you don't know, you can probably get the gist by just looking at this. So superhero is a thing that has a real name and a superhero name and powers. All right, so like by real name, I mean like Clark Kent. Superhero name is Superman. Powers include like, I don't know, flying and like laser beams, their age, what team they belong to. If they don't belong to a team, it's none. And then how many planets they've saved. All right. So even if you don't totally 100% understand classes, this is fine. Like you will be able to figure out what these mean. In program.cs, I created a very long list of superhero classes, each with their own superhero. So we've got Hal Jordan for Green Lantern. We got Bucky Barnes for Winter Soldier, Batgirl, Superman, all sorts of, heroes that we all know and love. All right, now I've got this big old pile of data. All right, so what can we do with it? We want to ask questions, right? That's the whole point. We want to ask questions. We want to query this data. So let's ask a question. Which Avengers can fly? That's it. Which Avengers can fly? All right, so now you may think well, that's a simple question. Well, actually, it's two parts. If you look at the data, right, if you look at superheroes, they have a property called team, which will indicate what team they belong to. So if we look at it, like some are Guardians of the Galaxy, Justice League, Avengers, etc., right? So their team has to be a certain value. And then in the list of string that represents their powers, it needs to contain flight. Okay, so for example, this person Captain Marvel has flight. Okay, well that's two things, right? There's two conditions we're looking for. The team has to be Avengers, and the list of powers has to contain flight. And with a where clause, we can do it. So what I'm going to do is list of superhero. We're going to do flying Avengers is equal to superheroes as the name of our variable that contains all this data. And we're going to use a where clause. And then inside we're going to put a lambda. And remember, a lambda is just a stripped down method. It's like a plastic fork, like a little plastic thing with the plastic fork and knife. You open it, you use it to eat your meal, and then you throw it away. Okay, that's what you can think of it just like that. All right, so we're going to do x. Again, we could also do rutabaga. Like it doesn't matter. It's just a variable. Okay, so x represents each superhero as it loops through the list. X.team equals Avengers. All right, notice how I did x.team here, all right, because x represents a superhero. Okay, so I'm going to do it like this. X represents a superhero. Each superhero object has a property called team. That's why I can use this dot notation to talk about the team. So team equals Avengers. Now, we have two conditions. They have to be on the Avengers, and they have to be able to fly. So I have two conditions, and they both have to be met. So in order to do that with where, it's pretty simple. Just like with if statements, we're going to use the double ampersand. And then we're going to do x.powers.contains, because it's a list of string. And then we're going to do flight dot to list. Now if you're like, wow, that's a lot. It's very long. I'm like, yes, they can get very long. It's fine. So superheroes.where x arrow x.team equals Avengers and x.powers.contains flight dot to list. This will answer the question of which Avengers can fly. All right, so what I'm going to do is we'll also learn a new piece of LINQ, okay, another method, because I don't want to write this in a for loop. I want to be able to console.log everything in flying Avengers, but I don't want to like necessarily write all this big like for loop. I don't have to. let's do flying Avengers dot ForEach. We actually have a method that will loop through our superheroes. Doing ForEach is exactly the same thing. Okay, I'm going to write some code beneath it. It's exactly the same thing as doing this. Superhero, hero, and flying Avengers. Okay, I could write all this out, or I could just write ForEach. Inside, I'm going to do a lambda that will represent each superhero as it loops through. So I'm going to do X, arrow, and then if I hover over X, you'll see it represents a superhero. And I'm going to console.writeLine X dot superhero name. This and this, let's do console.writeLine superhero name. These two will achieve the same thing. This ForEach loop and then doing the dot ForEach method will achieve exactly the same thing. The ForEach method like this is more declarative, right? It's just like, I just want you to loop through these things and then do what's inside what the lambda tells you to do. Also, it fits on one line. I would personally not care which one you use, but I like this because like it's much more compact and readable. All right, so let's go ahead and we're going to go ahead and print out all the Avengers who can fly, and let's see who that is. Okay, Thor, Captain Marvel, and Falcon. All right, that makes sense, right? That makes sense. Thor kind of throws a hammer and flings himself around. I don't know if he can, technically speaking, fly. I could be wrong on that. Let me know in the comments. Captain Marvel and Falcon, though, definitely 100% can fly, and they're all the Avengers. All right, so that's where and comes in. So and is when you have multiple conditions, and they all have to be true. You can have as many ands as you feel like. You can have 3 ands, you can have 10, you can have 100. I don't recommend having 100. Because that would be something else to type out, but if that's what you wanted to do with your life, then that's what you could do. Okay, cool. So now, another question. Which superheroes have superhuman strength or expert hand-to-hand? What's another power we could do? Telekinesis. Telekinesis. Let me see how to spell that. Telekinesis. Okay, K-I. All right, it's K-I. Okay, not a super common word. All right, so which superheroes have superhuman strength or telekinesis? All right, so this case, they could have both. They could be like telekinetic and have superhuman strength. That's awesome for them. But I just care if they're either one of these categories, I'd be okay for them to be back in my list. So let's do this. List of superhero. Strong or mind powers equals superheroes dot where x dot powers dot contains superhuman strength. That covers the first condition. Now the other one, again, they could have superhuman strength or they could have telekinesis. So if we're going to use or, just like with if statements, we're going to use or x dot powers dot contains X, that contains, what was it, telekinesis. There we go. Dot to list at the end. All right, so now with this or clause, like with or, I'm going to bring this down to the next line so we can see it a little bit better. All right, so we have where x arrow x dot powers dot contains superhuman strength or telekinesis. So I don't care. They can have both. Like, that's what they want to do. If they're like that awesome, they can have both. All right, so let's go ahead and see what this looks like. Strong or mind powers dot ForEach x console dot writeLine superhero name. Let's go ahead and copy and paste this from the top. And then let's do the little semicolon and let's run it. Let's see. Oh, let me go ahead and comment this out so we don't see both of them together. Okay, telekinesis or superhuman strength. Okay, and it's quite a big list. Scarlet Witch, Gamora, Drax, Captain Marvel, Cyborg, Hulk. Okay, so most of these I can tell, like, they're strong. I guess Scarlet Witch would have telekinetic powers, right? But I don't think Aquaman does. I could be wrong, right? But you can see that, like, most of these, like, they're in either one of the two columns. So or does that for us. Or just basically says, hey, if this is true or the other one's true, I'll put it in the list. Let's notice, you can see the difference if we change this to and. Or if I change this to and, let's see if there's how it changes the result set. Nothing. Okay, there's no result. All right, so that basically means there's nobody that is both has superhuman strength and telekinetic. Okay, so they're either one or the other. All right, cool. So now with where, we know that we can use multiple conditions. So we can have and if both things have to be true, or if either one is true. And again, you can have as many ands and ors as you so choose. Again, I wouldn't have too many, but like whatever you need to do. We also learned ForEach, the method ForEach, which allows us to basically write a for loop in one line. Okay, so we have dot ForEach, and then we use a lambda. So we have x arrow, and then what do we want to do with x? So in this case, I did console.writeLine x.superhero name. That way I didn't have to write a really big for each loop every time I wanted to like print all the superheroes I got back in my result. All right, so there we were able to use where, and we were able to use multiple conditions. All right, let's chain some of these clauses together and do some real work. All right, so the question we'd like to answer is, how many planets have the Avengers saved? Right? How many planets have they saved in total? Okay, just to make it really clear. All right, so each Avenger individually has saved a certain number of planets, but if I add them all together, what would I get? All right, so if you think about it, there's really two steps to this. First off, I've got my big data set. So let's go ahead and formulate our query. So in planet saved is equal to superheroes, which is the full data set. Then we want to sort of like filter it down, right? And filtering we use where. I don't want every superhero. I only want superheroes whose team is equal to the Avengers. Okay, everyone else can just take a hike. All right, so we've pared it down just the Avengers. Now, of the Avengers, I want you to sum up. We'll use a different variable here, y dot planet saved. So now we've chained the two things together. I now have a where clause, and I have sum. And I put them together. And now I can answer my question of how many planets have the Avengers saved. Then I will do console.writeLine. Okay, string interpolation, planets saved. And we'll do planet saved. Okay, and then we will run it. Okay, 65 planets. They've saved 65 planets. The Avengers do a great job. So again, superheroes is a full data set. Where will filter it down, pare it down to a smaller data set. Okay, so only the heroes who are Avengers, and then of the heroes who are the Avengers, sum up the planets that they've saved. And just to show you that it's different, we're gonna put Justice League here and see how the Justice League did compared to Avengers. All right, 35. So Justice League needs to get on it. All right, they have not saved as many planets as the Avengers have. So now you can see that like LINQ is all about chaining this stuff together to answer the question that you want. So you could always do more. You can chain them together. Notice how that we're putting where before the sum, because of the superheroes, I only want ones that are in the Justice League. So when you ask your question, you will have to think to yourself like, what things will have to go in what order. But this is just to try to demonstrate to you that you can chain these things that we've been learning together in order to get the data that you want. So far, what we've been doing with LINQ is we've been asking it for sets of data. So for example, I have this big set of data with all these superheroes, and I would ask LINQ like, hey, give me everyone who's in the Justice League. Well, people who are in the Justice League, right, are a group of people, right? So it's like a smaller data set within a data set, right? But what if I don't want like a list of things? What if I'm just looking for like one person? Like, so for example, let's say we had like a website and it was like, hey, like what's like Aquaman's like first name, right? Like what's his actual real name? Maybe you forgot, right? So you're not looking for like all people, like there's only gonna be like one Aquaman. You're like looking for one thing. You're not looking for like a set of things. All right, and LINQ's got you there. So LINQ basically says, okay, cool, I can search for and give you back one thing. All right, so we're gonna do superhero, hero is equal to, and then we're gonna give the data set. So superheroes is the data set, that's the full thing. And we're going to filter it. I'm looking for, all right, you can do this a couple ways. We're going to do with where first, and I'll show you how you can condense it. So we're going to do where x dot superhero name is equal to Aquaman. All right, so let's say I know there's going to be like one Aquaman. There's not like multiple Aquamen. So after the where clause, instead of doing to list, instead of giving a list of everyone named Aquaman, I only want one. Now we're going to use FirstOrDefault. Okay, there is a method called FirstOrDefault. Now it'll give me a warning here, which is fine. All right, so it'll be like possible no literal, but let's just do this as an example. All right, I'll show you how to rewrite this. But what this is basically saying is filter out the superheroes where the superhero name is Aquaman and give me back the first one you find. Okay, if you don't find one, return null. All right, so let's go ahead and run this, and I'm going to console.log console.writeLine, excuse me, JavaScript showing through, hero dot real name. So it can, let's make it spicier. So hero's real name is, and then we'll do hero dot real name, because remember, I want to get the first superhero object that fulfills this condition. All right, so I'm going to go ahead and run it. Okay, hero's real name is Arthur Curry. All right, so you're like, whoa. All right, so what FirstOrDefault does basically says is, hey, like, you want me to go look for someone, like, pare down this data until you find someone named Aquaman, and then hand them to me. Right, the first one you find, give it to me. We can rewrite this. Superheroes.FirstOrDefault x dot superhero name is equal to Aquaman. Okay, so you could do it something similar to this. Okay, just gotta put one more equal sign here. Oops, there we go. All right, and so it will complain at me a little bit, saying that like its superhero is not null here. So like in case this is null, we know it's not in our data set, but let's just say for the sake of argument, it's not. All right, so we can also write it like this to be more condensed. Okay, let's go ahead and run it. Okay, hero's real name is Arthur Curry. Now, here is the kicker. FirstOrDefault can give you one of two things. If it finds the thing you're looking for, it will hand it back to you. However, if it doesn't find it, because there's no like guarantee that like what we're looking for is in our data set. So let's say, for example, I put in some random superhero, the Carpet Man from the Tick, my favorite superhero, Carpet Man. Okay, so we have Carpet Man, and so now we're going to see, I'm going to put a debug point on line 39 and show you what happens when we look for Carpet Man. Now, I don't think Carpet Man's in my list. I'm going to run my program in debug mode, and it should stop. All right, and we're going to hover over hero. Null. All right, so hero is null. So that's how FirstOrDefault works. So FirstOrDefault says, okay, cool. If I find it, I hand it back to you. If I can't find it, you'll get back null. All right, and now as the programmer, we're going to have to do a little bit of null handling to make certain that, like, hey, our program works in case hero is null. Because as it stands, if I continue, it's going to throw an exception because I basically say hero.realName, but hero is null, so that you can't do real name of null. There's nothing there. So what I have to do is if hero does not equal null, then I can put this inside. And then notice how that warning went away, because now this line of code will only be read if hero happens to have some sort of value. All right, so which is pretty cool. So now FirstOrDefault allows us to check to see whether or not something exists in our data set. If it's there, we'll get it back. If it does not exist, we'll get null. We also have first, and first is a bit different. Okay, first is not going to give you back null if it doesn't find it. So, for example, let's do first of Aquaman again. All right, so here we go, Aquaman. Let's run our program. Arthur Curry, just as we expected. Same thing as FirstOrDefault. Here's the difference. Let's say the Tick. Okay, my other favorite superhero is the Tick. Let's go ahead and run our program. We get an exception. Sequence contains no matching element. Basically, that's computer speak for, hey, I couldn't find the thing you were asking me for. All right, so the difference between FirstOrDefault and first is that first will throw an exception if it can't find the thing you're looking for. All right, so you'll have to put it in a try catch to make sure that your program doesn't crash. Most programmers prefer FirstOrDefault, to be perfectly honest with you. If FirstOrDefault makes for much, softer landing in case we can't find the thing. All we have to do is use the if statement to do some null handling in case we can't find it. All right, so FirstOrDefault will hand you back a single thing. Now, the other thing you have to know about FirstOrDefault is it will do the first thing it finds. All right, so let me show you what that means. So let's do FirstOrDefault x.team equals Avengers. Now you may be thinking, well, Jonathan, there's multiple Avengers. Like there's more than one Avenger. Right? And that's true, right? So is it going to give me back all the names of all the Avengers? Well, FirstOrDefault only gives back one thing by definition. It cannot give back a collection of things. So if I run this, Tony Stark, right? How did it come to Tony Stark? Well, Tony Stark is here. He's also an Avenger. He's also the first one on the list. So what FirstOrDefault will do if there are multiple things that fit the condition is it will find the first one and then stop. All right, so for example, if I change Tony's, let's say Tony leaves the Avengers and he, I don't know, goes like solo, all right, and it comes none. Now if we run it, Peter Parker, okay, because Peter Parker is Spider-Man, is at the top of the list, right? So it goes to the next one, and then the next one, and then the next one. All right, so again, FirstOrDefault just looks for the first one it finds. If there's other ones down the road in the data set, it's not going to pick up on those. So you need to think to yourself when you're querying your data, like, do I really expect to only get one thing back from this or not? That's a question you have to consider when formulating your query, right? Because that means that you have to have some familiarity of the data set. But FirstOrDefault is your tool. Okay, remember, FirstOrDefault returns the thing you're asking for or null if it cannot find it. First will return the thing you're asking for or throw an exception if it cannot find it. So you need to be able to deal with both of those situations as you're coding. Much like FirstOrDefault, SingleOrDefault is also looking for a single thing, right? So let's say, for example, we're asking the question like, give me a superhero whose superhero name is Drax the Destroyer, all right? So superhero equals, and then our data set is superheroes, right? Dot, all right? Now, we can use single or SingleOrDefault. Let's use SingleOrDefault first. SingleOrDefault, x arrow, x dot superhero name equals Drax the Destroyer. All right, so oops, one more equals, and there we go. All right, cool. So let's see what happens. We're going to console.writeLine, string interpolation, regular name is, and then do superhero dot real name. All right, and let's see what happens. Let's take it for a spin. Cool. Regular name is Drax. All right. So cool. It found the hero. It looks like it does what FirstOrDefault does, right? So just like FirstOrDefault, if it doesn't find the thing, let's misspell Drax. All right. Then what will happen is that we'll have to do some null checking. So for example, there's nothing with Drax with two X's, right? So we'll have an object, no object reference not set to an instance of an object, right? So what we'd have to do is just like with FirstOrDefault, we have to have like a if superhero does not equal null. Okay, and then go ahead and put this in there, all right? So that way when we run it, our app doesn't crash. So this looks like the same, right? It's like they're basically the same thing. So it, like single, right? If I do single, then it won't give me back null. It will just crash in case I can't find it. So for example, there is no Drax with two X's the Destroyer. It will throw a sequence contains no matching elements. Okay, so what's the difference then? Like why have FirstOrDefault and SingleOrDefault? Okay, well, what will happen basically is that SingleOrDefault are expecting that there's only one element of that in the entire data set. Let's change our query around, and let's go ahead, instead of like filtering based on the superhero name, let's do it on the team. So let's just say like let's get rid of all this stuff. Team is equal to Avengers. Now, with FirstOrDefault, when I did this, it gave me the first Avenger that I had found. So it gave me Tony Stark, okay, and just ignored everything else afterwards. What will happen here, right? Because there's definitely more than one Avenger, all right? There's definitely more than one person in the Avengers team. So if I run this, it's going to give me this exception, invalid operation exception, all right? Sequence contains more than one matching element. The main difference between SingleOrDefault and FirstOrDefault is that you use SingleOrDefault when you expect there to be only one thing coming back. So for example, when I did SingleOrDefault, like the name was Captain Marvel or Drax the Destroyer, there's only one Drax the Destroyer in this entire data set. There's only one Captain Marvel in this entire data set. So you use single or SingleOrDefault when you expect there to be one of the thing you're looking for in the entire data set. Okay, if there's more than one, it will throw an exception. Okay, if you think that there's going to be more than one and you want the first one on the list, use FirstOrDefault. If you expect there to be only one in the entire data set, then use SingleOrDefault. Now, to be perfectly blunt with you, SingleOrDefault is really not used all that often because a lot of times you have absolutely no idea if there's only going to be like one in the entire data set. But if that's important to you, like if you want to make certain that stuff is unique, for example, then this could be very useful, all right? So again, SingleOrDefault will give you back the thing you're looking for or null, And single will throw an exception if it can't find the thing. And single or default will throw an exception in any case if there's more than one thing of which you're looking for. So for example, we went looking for Drax the Destroyer. There's only one Drax the Destroyer, so it works fine. If I'm looking for anyone whose team is Avengers, well, there's going to be more than one person in that little sub data set. So single or default will throw an exception. All right, what if you want to put things in order? All right, so let's say, for example, we'd like to have all these superheroes like in order of their superhero name. Because right now it's like whatever, like S, W, D, like it's not in any sort of real order. All right, so we're going to do list of superheroes. Okay, list superhero. Let's say ordered list is equal to superheroes. That's our data set. Oops, superheroes. Thank you, IntelliSense. And we're going to do order by. All right, order by allows us to basically take some data and put it in order based on one of the properties. So for example, superheroes have a superhero name. So what I'm going to do is I'm going to use a lambda here. X dot superhero name. And I'm going to make it a list. All right, so superheroes dot order by X arrow X dot superhero name dot to list. So what I'm saying is take a superheroes and then reorder them by their superhero name and give me a list. Then I'm going to do ordered list, and we're going to use that for each we saw earlier, for each X, and then we're going to console.writeLine X.superhero name. Okay, so we're going to put all the superheroes in order based on their superhero name, and then we're going to, for each of them, write out their superhero name to the console. So let's see what that looks like. All right, so I'll make it a little bit bigger because we have all of them. Black Widow, Captain America, Captain Marvel. So as you can see, it starts at B and goes down to W's, right? So order by took all of our heroes, looked at their superhero name, and then put them in order based on that. Now let's say you didn't like this. Let's say you didn't like the going from like B to W. Let's say you wanted to go the opposite direction. So there's also order by descending. Okay. So there's order by and order by descending, and then we will go ahead and run this. Let's take a look at what it gives us. So here it starts at W and goes up to A. All right, so order by will go from the the least to the greatest, okay, up to down, and then if you like to flip it, you can do order by descending. Okay, so you do have to use to list afterwards. Order by descending and order by are going to give you back that dreaded IE enumerable. Okay, so if you want to just use a regular list, you're going to have to use this to list method at the end, but then you'll notice that it will just order it by whatever you ask it to. All right, so that's really good because we were able to take our data, which was all like sloppy and all over the place, and we were able to put it into a nice alphabetical order. So sometimes our query can be kind of a yes or no question. All right, so for our question this time, we're going to ask, can any of the Guardians of the Galaxy fly? All right. So essentially what we're asking is, I don't care like which one can fly or how many can fly. I don't care about that. It's a yes or no question. Can any of them fly? If even one of them can fly, then the answer will be yes. If none of them can fly, then the answer will be no. All right. So always kind of focus on what is the question asking, and don't stray too far away from the question. So to answer this question, it's going to be a Boolean, right? Because Boolean makes sense. Boolean is yes or no. All right, so Boolean, Guardians can fly, right? So there is at least one Guardian of the Galaxy who can fly. So here's my data set superheroes, and let's learn any, okay? Any gives you back a Boolean, all right? So any basically says, hey, are any of the things in this data set match this criteria? If even one does, it will return true. So it doesn't really matter if it's 1 or 10 or 10,000, right? They're all going to return true. Okay, so any does not answer the question of who can fly. It answers the question of can any of them fly? Yes or no. All right, so inside any, we're going to put X arrow X dot powers dot contains, and then we're going to put flight. Okay, and that's our query. All right, can any do superheroes dot any X arrow X dot powers dot contains flight? Notice how contains itself is a Boolean, right? Could either contains the thing or it doesn't contain the thing. All right, so we're looking to basically to say like, hey, like, can any of them fly? And so what we'll do is we'll just go ahead and write that out to the console. Guardians can fly, and with drum roll, we'll see if that is correct. True. Okay, at least one hero in the Guardians of the Galaxy can fly. Who are they? I have no idea. Okay, any does not answer that question. Right? Any does not tell me how many there are or who they are. Any just says, hey, like at least one of them does. All right, so if you ever have like wonder, like in this set of data, can I find at least one example or one thing that fits this condition? Any is the correct way to go. All right, so again, the syntax is superheroes.any x arrow x.powers.contains flight. Now be very careful with like what you put inside here, because it needs to be able to be true or false. So for example, x.team equals Avengers. Okay, so like you could say like this is fine, right? Like are there any Avengers in my entire data set? Okay, they're Avengers, or their first name, or they have a flight. Like basically whatever condition you want to put in here, all right, as long as it basically can evaluate to like true or false. Okay, Any will tell you like, hey, yes, there exists at least one thing that meets this criteria, or no, there are none. Let's ask another question, another query. Can all of the Avengers fly? All right, so this is a little bit different than asking can any of the Avengers fly. So can any of the Avengers fly means can you find at least one Avenger that can fly? This question says I want to know if all of them can, like every last one of them. Like if even one person can't fly, then it's false. Okay, so this is again a yes or no question. Either they can all fly or they can't. Okay, it's an all or nothing proposition. And we can capture that with a Boolean. So Boolean can all fly equals superheroes dot, and then what we're going to use is all. Okay, so we're going to use where first actually to get the Avengers. So we're going to do x.team equals Avengers. So of the Avengers, then we'll use all. Okay, all asks the question, do they all share this? Okay, all of them. If even one doesn't meet this condition, then we will return false. If they all meet the condition, we will return true. So we're all y arrow y.powers.contains, and then we'll put flight. Okay, so this asks the question, can all the Avengers fly? This will be the answer. So we'll console.writeLine, and I can put can all fly, and we'll see what happens. Okay, nope. Not all the Avengers can fly. Now maybe some of them can, right? So Any would be able to answer the question if some of them can, at least one, but they all cannot fly. All right, so just to kind of show you what this looks like, we look at the Avengers, right? If we look at their powers, like Tony Stark has a power armor suit. I guess technically speaking, he can fly, but we have wall crawling, so some of them can, right? But some of them can't. Okay, like so for example, here we go. Thor can fly, although I think he just swings his hammer, right? But all essentially says, hey, everything in this data set, do they all have this condition? Every last one of them, no exceptions. Okay, if even one of them does not meet the criteria, then it returns false. If they all meet the criteria, it returns true. So this could answer questions like, can all the Avengers fly? All right, let's ask a different question. Let's ask a question saying, basically, out of all of these superheroes, like, what teams are there? And in this whole big batch of superheroes, like, what teams are there? So, what teams are these superheroes on? Right, so we can answer that question. So what we can do is basically we want to pull out one aspect of the data that's in this big old data set. So what I mean by that is like superheroes, right, have different properties, real names, superhero name, powers, age. I just want to like pull out like one of them or maybe two of them, right? I don't want like the whole enchilada. I don't want the whole superhero. I just want to like pull out one aspect of the superhero. All right, I want to select one aspect of the superhero to get. So what we can do is we can basically say we'll do var teams is equal to superheroes, which is their data set, dot select. Okay, so select is basically saying I would like to select one aspect of this object, right? We have a class and it has powers and a team and first name and whatever else. You want to just select just those pieces of information, not the whole thing, just that one part. So I want to select the team. So I'm going to do x.team and make it a list. All right, so I'm going to have a list of just the teams. So if we hover over teams, we'll see it's a list of string. All right, so I'm going to just go ahead and just to make it clear, I'll just go ahead and do list of string. Okay, and then what we can do is we can use that for each we learned earlier. Okay, x console.writeLine x. Okay, so whatever the team is. So remember, each thing in the team is, so we'll just, actually just for complete and utter like clarity, I'll just rename the variable team. All right, and then I'm going to go ahead and do console.WriteLine, and as you can see, okay, we've got Avengers, X-Men, Justice League, Guardians of the Galaxy, Justice League, none. Okay, so as you can see, what select does is it says, okay, cool, go through each one of these and just pull out the team. That's it. I don't want the other stuff, the name, their powers, whatever. I don't care. Just select just the team. So if I, for example, did x dot, let's do real name. All right, I'll just leave everything else as is. Then you'll notice it'll just give me their real name. That's it. All right. So if you would like just one column or one aspect of the data, you can use select to get it. So you may have noticed with team, though, that we had a lot of duplicates, right? Like Avengers appears multiple times, Guardian of the Galaxy appears multiple times. That's not a really great list. Like, what teams are these superheroes on? It does answer it, but like we have a lot of duplicates. All right, so what I'm going to do is I'm going to use another LINQ method that will get rid of the duplicates. All right, we're going to do distinct. Okay, so what this does, like, we're chaining things now. So first I'm saying, okay, give me all the teams of the various superheroes in my data set. Then give me the distinct ones, so the ones that aren't copies, and then make it a list. So now when I do this, Avengers, Justice League, X-Men, Guardians of the Galaxy, none. See how all the duplicates just went away? Okay, so distinct will basically say, okay, of this group of data, I would like the distinct or the unique values. Okay, there's duplicates of a value, get rid of the duplicates. I don't want the duplicates. And that makes sense, right? To answer the question, you wouldn't say, like, what teams are there on this list of heroes? Avengers, Justice League, Justice League. You wouldn't say that. You would say Avengers, Justice League, X-Men, etc. I actually don't like the way that looks, so what I'm going to do is I'm going to do order by. All right, and then I'm going to just basically do X. Okay, I'm just going to use itself because X is a string. All right, so I wanted to do this just to show you that you can just do it itself. So remember, select x.team is giving me a list of string. Take that list of string and give me the distinct values. Okay, so I have another list of string with these distinct values. Then order that list of string, okay, and then give me a list. So you can see how we're like chaining all these things together to give us our data exactly the way that we want to. So now, when I get my list of teams, it's Avengers, Guardians of the Galaxy, Justice League, none, and X-Men. It's in order. All right, so now I basically taken all the superheroes, pulled out their teams, got rid of the duplicates, put it in order, and then made a list out of it. See how powerful LINQ is? It's really fun. All right, so you could be able to take your data and like present it. So now, like, I can know exactly how, like, what teams the superheroes work for, or maybe they don't work for any, and then put them in order and display them in a nice list. So I did first with select. Select will select a single column of data, a single aspect of the data, and then distinct will get rid of all duplicates in the data set it's working with. All right, let's ask another question. So what I'd like to know is I'd like a list all the real names and superhero names of all superheroes. All right, so this sounds like select because I want to get just like these two columns, these two pieces of data from all my heroes. Like forget the powers, like forget the other stuff, their age, the number of planets they save, forget all that stuff. I just want their name and their superhero name. All right, but we know how to select one thing. We don't want to select multiple things. Now, what we're going to do is we're going to use a little what's called anonymous object. Okay, so what that basically means is normally when we work with objects, they have names. So, for example, we had a class called superhero, so we could create new superheroes, and each one of them would be an instance of superhero. They have a name, superhero. But when we do select, we're going to use an anonymous one, meaning it has no name. So what we're going to do is we're going to do var. We're going to do superhero name list. That's what we'll call it. Okay, superheroes is the name of our data set, and we're going to select X. Now here's the different part. We want to do two columns. We want their superhero name and their real name. So we're going to do new squiggly brackets. Okay, so this creates an anonymous object. Okay, notice how after new we're doing an object. There's no name. This object has no name. There's no class that represents this object. So we're going to do let's see, real name is equal to x dot real name. See how like I did this real name equals x dot real name? X represents the superhero. I could have called this rutabaga. Okay, it's an anonymous object, so its properties are up to me. Okay, there's no class blueprint that this points to. Okay, obviously name them something real, but I'm just pointing out that it is what you want it to be. Okay, but this part, the x.realName, that actually is tied to a real class, where that is a real property of it. So we have real name and superhero name is equal to x.superhero name. All right, and then we'll make a list. Okay, and just to keep it so that I will move some stuff around so you can see it a little bit better. Okay, and let's say I want to order it. Order by x dot. Okay, let's order by their real name. All right. So notice how the IntelliSense, if the real name popped up. So I do x dot, right? So it's real name and superhero name. We hover over what x is, it says a, right? So essentially it's an anonymous object. It's not based off of a class. We're just basically ad hoc saying, hey, here's this object and here are its properties and here are their values. It will not be useful after this point, okay? But we basically say we don't want to go ahead, like we could create a little subclass that just has these two properties in it, but that's really that's overkill. We could just create an anonymous object like this, declare its properties, and say, okay, cool, real name is the superhero's real name, and the superhero name is from the superhero class. And then let's go ahead and use that ForEach loop, superhero name list dot ForEach x console.writeLine, and then we'll go ahead and let's do string interpolation. So we'll do hero name, and then we'll do x dot superhero name, and then we'll also do real name. Oops, still inside the string, real name, and then x dot real name. A lot of typing, I know. All right, let's go ahead and run this. Okay, hero name, Batman, real name, Bruce Wayne. Okay, hero name, Aquaman, real name, Arthur Curry. So you see now we are able to essentially select two columns. The first column being the hero name, the second column being their real name, and then we're able to display it. Now I probably have to do a little bit of work to make this look a little bit better, but you get the idea. All right, so to sum up, we use select, and instead of just selecting a single column, we wanted to select multiple columns. So we create an anonymous object. An anonymous object, anonymous means no name. Okay, anon, like no name, anonymous, right? Anonym, so like no name. So we had new and then curly brackets, and then we just created properties. I just decided to call it real name, and that's it, real name equals x.realName. Again, this could have been rutabaga. All right, and then I ordered them and then did to list. All right, and I was able to select multiple columns this way.